Good afternoon to one and all. Myself, Dr. J. Namrata Manohar, is back with the 6th episode on tips to master computer programming. You may recall that so far I had presented 11 episodes covering 4 aspects. 1. Computer programming. 2nd. Embedded systems. 3rd. On making research thrilling. And 4th. On motivation to youngsters. As regards computer programming, in my first episode, I had presented 46 queries or questions, the answers to which I had asked you to seek so that you get a strong foundation of the programming language and you can expertise your programming skills. In the second episode, I had presented the preliminary terms of computer programming. In the third episode, I had presented answers to the questions 1 to 20 as related to C programming. And fourth episode, questions 21 to 30 as related to C programming language. Fifth episode, we had answered the questions 31 to 33. Now, in the sixth episode, let us discuss the answers to the queries 34 to 35 as related to C programming language with some programming examples and quiz questions. Now, first, these are the various links to my previous 11 episodes. I request you all to once go through the episodes of programming language after listening to this video or even before listening to this video, so you get a strong foundation. Now, in the previous episode, we had discussed about the conditional statements in C. The 3 conditional statements are if-else, condition, colon, true, ternary operator, and the switch statement. And in if-else, we have the various if-else, if, and nested if-else, or what is as a if-else ladder. So we'll just see a small example using this if-else statement. Now, write a C program to calculate the electricity bill using if-else statements given. For the first 50 units, it is ₹3.50 per unit. For the next 100 units, ₹4 per unit. For the next 100 units, ₹20 per unit. And for the units beyond 250, it is ₹6.50 per unit. So first, what is the logic? As I had explained to you about the steps in programming, you have to decide what are the variables that are needed. So the variables needed for our programming here are the total bill amount and the number of units consumed. So float, bill, units consumed. Now, what would be the logic? Here we are using if-else statement. So here, first we should understand the question as I had explained. For the first 50 units, it is ₹3.50. So first accept the number of units consumed. After accepting the number of units consumed, if the units is less than or equal to 50 and it should be greater than equal to 0. Why do we need to check this condition? Units greater than equal to 0. Because if you are not entering 0 or by mistake you might be entering some -45, then it may give you an error in the programming. So we have to check that the units is greater than 0, and if it is less than or equal to 50, the bill amount is whatever number of units you have consumed multiplied by ₹3.50. This is the printf electricity bill percentage rupees bill. Now, if your units is more than 50, then we have to check if it is less than or equal to 150, because for the next 100 units, for the first 50 units, it is ₹3.50. So bill is equal to 50 into ₹3.50. And beyond this 50 units, how many units you have consumed? Minus 50 into 4. That will be the electricity bill. Now, if it is beyond 150, then for the first 50 units, if it is less than or equal to 250 and units greater than 150, bill is equal to first 50 units ₹3.50 plus 100 into 4, because beyond 50, 100 units, it is ₹4. So 4 plus units minus 150 into ₹5.20. Then it will compute the total bill and display the bill. Now, if the units is greater than 250, then all these calculations we have to do. That is, first 50 units into ₹3.50, next 100 units, ₹4, again, next 100 units, ₹5.20, and the next balance of the units is units minus 250 into ₹6.50. This will give you the total bill. So, else printf Please enter valid consumed unit. If there is any mistake in your entry of entering the number of units, you prompt that please enter valid consumed units. So this is the logic. So the number of variables, what you have to use, and the logic is what you have to design. Now, in this particular episode, as I told, we will be discussing about question number 34 and 35. So here in 34, we are going to discuss what are the looping structures. Now, looping structures in C are of three types. For loop, to repeat a task again and again. Then say you want to repeat a task again and again. You want to enter your name 10 times. Then you need not keep on writing printf, scanf 10 times. You can write printf and scanf only once and write it in the for loop. So looping is repeating a block is met. So you keep on repeating. You want to print the numbers 1 to 10. Then the loop statement allows programmers to execute a statement or a group of statements multiple times by writing the code only once. So you write the code only once, but number of times you can display it. As I said, you want to enter your name 10 times. You write your name only in one statement, that is one printf statement. But you can write using either for loop, while loop, or do while loop, you can print it 10 times. Now, what are the advantages of the loops in C? In your interviews and exams also, you will get number of questions relating to this loop structures, right? So loops reduce the number of lines of code. Lines of code is LOC. As I told you in the previous episode, the lesser the number of lines of code, the faster will be the execution and more efficient will be your programming. And your programming skills also will be judged by the number of lines of code you write. Now, it saves time and effort and increases the efficiency. Time of writing the program, then effort of writing the program, and it would increase the efficiency as it executes fast, and debugging also will be easy. Reduce the chance of getting errors during compilation. So the number of errors displayed also would be less. Loop makes the code readable and easier to understand, especially when dealing with complex logic or large data set, because the number of statements you are writing less, but you can execute it number of times. So that's why it becomes easy. And it provides code reusability. This is the concept of reusability. Now, what are the errors that we would be getting in computer programming while executing your looping structures, right? So counter variable not initialized. If the counter variable is not initialized, since suppose you want to display your name 10 times, you need a counter which keeps on incrementing 10 times. So that is called as the counter variable, which will be seen in our next slide. Counter variable not initialized, that would be the error. Or counter variable not updated. You have to keep on updating your counter. Then condition value not meeting logical requirement. If your condition value is not logically meeting your requirement, also you'll get an error. Variable data type not appropriate. These are some of the errors which you might get related to compiling of looping structures. Now, how to avoid errors and correct errors? Check the program. Check the program 2 to 3 times for any typographical, syntax, and logical errors. Then identify and correct them. Now, trace the program logic. You should always trace the program logic. I will explain to you how to trace your program logic. Then compile the program, right? You should compile the program. When you're compiling, what are the errors you will get? You note down and you rectify the errors, and you keep a note of these errors and how you are rectifying, so that in your subsequent programs, if you get the same errors, it is easy for you to eliminate the errors or correct the errors. Recompile until compilation is success. So this process you are going to repeat. First, you check for yourself by reading the program whether there are any typographical errors, syntax errors, or logical errors. After identifying and rectifying them, this tracing of the logic, then compile the program. Whatever errors you're getting, you make a note of that, rectify that, again, compile it. And then once, and you keep on compiling, debugging, and then redesigning and recompile until the compilation is a success. Once it is successful, the program is without any errors. Note for any runtime errors. Rectify, recompile until success, and run the final execution together. This is the practice you should adopt for your programming. Now, what are the various types of loops? Loops are basically classified into two types: entry control loop and exit control loop. Now, what is entry control loop? Entry control loop is the test condition is checked before entering the main body of the loop, right? Now, in the exit control loop, the test condition is evaluated at the end of the body of the loop. That is, in exit control loop, since you're testing the condition at the end of the body of the loop, body of the loop will be executed at least once, irrespective of whether the condition is true or false. So if you wanted to execute at least once, whether it meets the condition or no, you use this exit control loop. Otherwise, you can use this entry control loop. Now, coming to entry control loop, there are two types, for loop and while loop. And in exit control, you have what is called as do while loop. We will see the syntax and some program examples for these three types. Now, coming to the simple for loop, which is the first one. First one is for loop. So we'll see the for loop. So what is the syntax of the for loop? For initialization, check or what is called as the test expression, then updation or increment. You have to have this, you have to keep this semicolon. So this is the syntax. Then you open the for loop with the open brace, and then you write the body of the loop and you close the body of the for loop. Now, so what is the flow chart for this? You're going to start, you're going to initialize the counter variables. Then you check the test condition, whatever is the check condition. If it is true, you execute the body block of the statements. And then after executing the block of the statement, you update your counter. Once you update your counter, again, you check for the counter variable. If the counter variable is within the limits, then it is false. You're going to come out of the for loop. So here we will just see a small example wherein you'll be printing the sum of the first 10 natural numbers. So what do we need? We need only a counter to print the 10 natural numbers. So here I need int I and sum is equal to 0. So I am going to use as a counter variable. So for I is equal to 1. Simple. So this is initialization. Initialization is I is equal to 1. Right? Then I less than or equal to 10. That is a test expression. I want to print only the 10 natural numbers. So I'm starting from I is equal to 1. So less than or equal to 10. Then I plus plus. That is, I'm going to increment. So what is the logic here? Sum. I've initialized sum to 0. Now I'm using this shorthand operator. This is sum plus is equal to I. It is equal to sum is equal to sum plus I. So now the sum has become 1. So how do you trace the program? The trace the program is you write your variable I and sum. And then sum is equal to 1. Sum has become 1. Now I will print the variable I. That means I will get the output 1. I'm going to get the output 1. Now, after printing the output 1, then printf sum of the first 10 natural numbers. Numbers is equal to %d sum. I'm printing the sum. So what is the sum of the first 10 natural? Here you can see here I've closed the for loop here, right? Now, so after printing this 1, you're getting output 1. Then what happens? It increments I. I becomes 2. When I becomes 2, it checks whether I is less than or equal to 10. 2 is less than or equal to 10. So 2 is added the for loop. Sum is equal to, sum was previously 1. So 1 plus 2, 3, 2. Now after it prints 2, then again the condition is I is incremented to 3, sum. Then again the counter I equal to 10. So again 4 is added to the sum. So this process repeats until the counter I is incremented to the value 10. Once it is 10, it prints the number 10. After it is 10, the 10 is incremented to 11. 10 is incremented to 11, right? I less than equal to 10. 11, this condition becomes false. And it prints the sum of the first 10 natural numbers, 5. So this is the initialization, and you can trace your programming by writing the value is working for loop. Now, coming to the while loop. This is called simple while loop, right? Now, what is a simple while loop? The while loop is an entry control loop. This loop can be used to iterate a part of the code while the given condition remains true, right? So what is the syntax of while loop? While, test expression, body consisting of multiple statements, and closing your while loop. So here, what is the flow chart? Entry condition, test condition. If test condition true, the body of the loop is executed. If it is false, it exits the while loop and execute the next statement in the main C program. Now, if it is true, it executes the body of the loop, keeps on then it again tests the condition. So this process repeats until the condition is met and the condition becomes false. So here we will just see the same program wherein you're displaying the numbers 1 to 5 and finding out the sum of the numbers 1 to 5. Main int I is equal to 1, sum is equal to 0. Now here in the for loop, I could initialize the I is equal to 1 in the for syntax only. Right? So here you can't initialize, you have to initialize this counter variable outside the while loop. So int I is equal to 1, sum is equal to 0. So these are the two variables I am using. Now, while I is less than or equal to 5, because I want to print the numbers 1 to 5 and find their sum. I is less than 5, open the while loop. Sum plus is equal to I. Now, initially I is 1. So sum becomes 0 plus 1, 1. And then you're printing the value of I, that is 1. Then you have to increment your counter. This is the counter variable, so I plus plus. You are incrementing the counter variable. So I plus plus, I becomes 2. But why I2 is less than or equal to 5? Since 2 is less than or equal to 5, what happens? Again, 2 will be added to the sum and 2 will be displayed. Then counter is incremented. That is 2 becomes 3. 3 is less than 5. So 3 is added to the sum. 3 is displayed. 3 is incremented to 4. 4 is less than 5. So 4 is added to the sum and 4 is displayed. Then 4 is incremented to 5. Since 5 is less than or equal to 5, 5 is added to the sum and 5 is displayed here. And then 5 is incremented to 6. Now when it is incremented to 6, this condition becomes false. I less than or equal to 5 becomes false. Since it is false, it exits your while loop and prints the sum of the first 5 numbers. Sum is equal to 15. So this is how the while loop is executed. Now, what are the errors likely to occur? Counter not initialized. So this is the counter. I is equal to 0. Counter not updated. You have not updated this counter here, or not valid condition. This condition is not valid. Sometimes you may, the condition is not valid. This may go into an endless loop. Then your computer system may hang. Now, the next one is do while loop. As we have said, this is an exit control loop. That is, a condition is tested while exiting the loop. Loop will be executed at least once. So what is the flow chart? Start, initialization of the loop counter, body of the loop, update the counter, while condition. If the while condition is false, then you are going to exit the loop. Otherwise, true, you again go increment the counter, execute the body of the loop and check for the condition. Now, what is the syntax? Do, open your do loop, then body of the do while loop statement, close the do loop, and then while, and then the condition, and then you close it with a semicolon. Now, here, as I told you, I will show you how to trace the program logic. Right? So this is how you trace any program that you write. You can trace like this, right? Now, this is the program to find the factorial of a number, right? So what is factorial of a number? Say the number is 5. 5 into 4 into 3 into 2 into 1 is the factorial of the number. So as I told, first of all, you should know the logic. You should understand the question. So what does factorial mean? How do you compute the factorial of a number? First, you should understand. Then only you can write your programming logic. So here, what are the variables required? First, the I, the number n, for which you want to find out the factorial. Then we have a counter I, and then fact, that is the factorial I'm using is equal to 1, initializing it to 1. This is very important because if you're not initializing to 1, maybe some previous program, somebody has used the variable fact, and fact may have some value, that likely that value will be carried over to this program and you may get a wrong output. So always initialize the variables correctly. Fact is equal to 1. Now enter the number for which you want to find out the factorial. So printf, enter a number. Scanf ampersand n. So n is the number for which I want to find out the factorial. So say I've entered the number n. I've entered the number. So here, while tracing, what are the variables? You write down the variables. You write down the variables like this, n and fact. N is initially 5. So what will be the factorial? First 5, right? Is factorial is 1. 1 into 5 is 5. Now, I is equal to n, and we're equating I to n. Now, do while loop. So do fact into equal to I. That is, fact is equal to fact into I. What is for fact? Fact is initially 1. So what is the I value? I value is 5. So I into 1 becomes 5. So the first factorial is 5 we are going to have. Now, minus I. I am decrementing 5 to 4, right? So 5 becomes 4. Now, while I is greater than equal to 0, I am decrementing this value. As long as this I is greater than 0, this process of multiplication will continue. Now 5 has become 4 here. 5 has become 4 here. Now, so 4 is meeting this condition that it is greater than 0. So it enters again the do while loop. Again, fact. So 5 into 4, 20. Fact becomes 20. After it becomes 20, again, this condition minus of I, 4 becomes 3. Do while loop. Again, 3, multiply 20 with 3 and you're getting 60. Right? 2 is greater than 0. So again, multiply this 2 with the fact. So 2 into 60. I becomes 2, from 2, it becomes 1. 1 is greater than 0 to 1, 120. Now, once you decrement I, it becomes 0. This becomes false. Once it becomes false, it executes the next statement after the do while loop in your main C program. So what is the statement in the main C program? Printf factorial of the number. Percentage D is equal to percentage D, that is n comma I. So factorial of 5 is this percentage D should have been equal to. So I have done a mistake here. So equal to should have been here, not is, equal to 120. So this is how you should be able to trace your program and see whether your logic is correct or no. You're getting the right output when you trace it. So in this way, when you're compiling, the number of errors will be less. Now, here in the do while loop, there are different types of do while loops. Then is infinite do while loop, empty do while loop, and nested do while loop. Now, what is infinite do while loop? The infinite do while loop has an infinite number of iterations. It is known as infinite do while loop. The test condition of the infinite do while loop never turns false. So this we should never do. Do while I is less than or equal to 5. Here initially I is equal to 1 I gave, right? So when I is equal to 1, I is less than or equal to 5 I gave. But here the counter, I'm never decrementing it, or I'm not incrementing or decrementing the counter. So I will always be 1. Since I is always less than or equal to 5, it keep on printing this word hello, right? So this is a dangerous situation because it will hang your computer. You will not be able to do any other work in your computer. So you should see that you be very cautious that you don't write infinite do while loops. This can be done only when systems say it's a practical situation and the system has to continuously do it, and or say you have a billboard and wherein you are displaying a message on the billboard, right? So, and you wanted to keep on printing that message throughout 24 hours, 365 days, then you can use this infinite do while loop. Now, empty do while loop, as the name indicates, it is one that does not have anything in its body. I is equal to 1 do, and you're not writing any executable statements in the loop, right? So this also you should avoid. Nested do while loop. Nested loop is one which has one or more loops within its body. That is do while within do while loop. So int main, int I is equal to 1, and I'm having another variable j. Do j is equal to 1, initializing j to 1. Do printf hello while plus j is less than or equal to 2. That is, instead of incrementing this within the loop and incrementing within this while condition, plus j is less than or equal to 2. J becomes 2. Now, since j is equal to 2, it stops. That is, this program will print this hello only once. So once it incremented, printf how are you, it is saying. Now, while I plus is less than or equal to 3. So here I was initially 1, plus I becomes 2. I is less than or equal to 2. So again, it will print, how are you, right? Now, how are you, it will print again, it increments I. When I is less than, becomes 3, then it will stop this loop condition, right? So this is how this nested do-while loops are used. Now we'll see a practical example. Write a program to find the equivalent resistance of 10 resistors in series using for loop. If the voltage is 240 volts and the current in the, find the current in the circuit. Now this is an electrical circuit wherein you are having, say, 10 resistors. And what is the equivalent resistance of this circuit is R1 plus R2 plus R3 plus R4 plus 5, 6, 7, 8, 9, R10. Then this voltage divided by this total resistance will be give you the current, right? Voltage divided by this total resistance will be the current. So here what we are going to use, we can use the for loop. So what are declare the variables for the counter I, resistance R, and equivalent resistance. Now for int I, resistance EQR, right? Int voltage is 240, they've already given you here. So float current. Now, since voltage divided by the resistance may give you a decimal value, that's why I'm declaring it as a float value, right? Now, EQR, equivalent resistance, EQR means equivalent resistance. So, as I told you, the variable name you should choose appropriately. So, the moment you see this word, you should be able to identify what it is telling you. It is equivalent resistance. EQR is equal to 0. Now, printf, enter the values of the 10 resistance in ohms. So here we are prompting the user to enter the value of the resistances. So I'm using a for loop. For I is equal to 1, I less than or equal to 10, I plus plus. Printf, enter the value of percentage D resistance I. That is, enter the value of, now I is 1. So that means I'm saying enter the value of the first resistance. Scanf, I'm accepting the first resistance, adding this resistance value to this equivalent resistance, right? So then I becomes 2. When I becomes 2, I'm saying enter the value of the second resistance and 2, right? Scanf percentage D amps, right? So here what is there? Enter the value of the first resistance and I'm accepting the value I, right? So here I'm in this way you will be accepting execution and output, enter the values of the 10 resistance in ohms. So you are telling the enter the value of the 10 resistance in ohms. Now this will print enter the value of percentage D resistance, enter the value of first resistance. The first resistance value I've entered is 12. Now then I becomes 2. So enter the value of the second resistance. This is the value of the second resistance the user has entered. Then I becomes 3. 3, third resistance, I becomes 4, I is 5, 6, I is 7, 8, 9, 10. When I becomes 10, this condition is met. I less than or equal to 10 is met. So when I is incremented to 11, this condition becomes false. First condition becomes false. So it comes out of the for loop and then it executes this statement. The equivalent resistance of percentage D ohms is equal to EQR. That is, the equivalent resistance is 81 ohms. So this is how you will be using your for loop. This is an example to show how you should use a computer programming to write programs for your practical applications, right? So the more programs you write for your practical applications, the more the sound you will have about your programming skills. Now, this is another program we are writing. Write a program to print the numbers 1 to 15 in the reverse order, right? So that is 25, 24, 23, like that I need to print, right? Find out the sum. So here hash include stdio.h. In the previous program, we had printed the numbers 1 to 10 and 1 to 5. But here they are asking the reverse. So here what we need, instead of incrementing the counter, the initialization will be the upper value and you'll be decrementing the counter instead of incrementing. So for I is equal to 15, I greater than 0, minus minus of I. So initially I is 15, you're printing I is equal to 15, right? Then and you're adding the value 15 to the sum. Then I becomes 14. So when I is 14, again you are printing 14, 14 is added to the sum. 14 becomes 13, 12, 11. So I is going on being decremented when I becomes 1. When I is 1, I is greater than 0 still. So I is added to the sum. But when you're decrementing I, it becomes as 1, it becomes 0. When this becomes 0, this condition is not met. That is, the for loops become false. So when the for loop is false, the execution, control comes out of the for loop. And this statement printf sum of the numbers 1 to 15 is equal to %d, sum is executed. And then you close your main program. So sum of the numbers 1 to 15 is equal to 120. So this is how, when you're writing this logic, you can also, again, as I showed you in the previous statement, you can retrace the logic. That is, write the value of I and sum, and at each step, at each iteration, you check whether the output is coming correct or no. Now, the 35th question is, what are the various jumping structures? That is, sometimes there may be necessity that when you're executing a program, you want to transfer the control from one point of the program to another point. So then we use what is called as jumping structures. So jump statements or branching statements are control flow statements that allow programmers to change the order in which a program executes. That is, instead of executing sequentially, you want to skip some executable statements and then go to the later part of the program. Then you use this jump structures. They are used to interrupt the normal flow of a program and jump to another section unconditionally. We will see how this will be done. Now, there are 4 types of jump statements in C language. What are they? Break, continue, go to, and return. Right? Break terminates a loop or switch statement prematurely and transfers control to the code that follows. So this is the break statement. Now continue skips the remaining code in the current iteration of a loop and move to the next iteration. Right? Now break statement we had already seen in our switch statement in the previous episode. Go to unconditionally jumps to a labeled statement within the same function. Right? And return ends the function and returns a value to the caller. The use of go-to statements is often discouraged because it can lead to code that is difficult to maintain. So normally go-to statements are avoided unless it is necessary. Now we will see the syntax of each of this: break, continue, go to, and return. So here we are seeing the break statement. The statements inside the loop are executed sequentially. When the break statement is encountered within the loop and the condition for the break statement becomes true, the program flow breaks out of the loop regardless of any remaining iterations. So here we will see how to use it. I is equal to 1, I less than or equal to 10, I plus plus. Though we are using the counter up to 10. But here we are giving within the for loop, I'm opening the for loop and saying if I is equal to 6, though I'm giving the iteration up to 10, I've given the condition if I is equal to 6, break, right? So what will be the output? The output will be only 1, 2, 3, 4, 5. If this was not there, as we have done in a previous example, all 10 numbers would have been printed. But here I'm giving the condition within the for loop. That is, if I is equal to 6, then break. So once I becomes 6, read the number and printf loop existed. Following purposes come out from the nested I. So I've explained to you in the switch case. Note, and a nested loop, it will break the inner loop, right? So this is the condition. Now, what is the syntax of the break statement? Break statement flow diagram, loop condition. If it is true, the loop code block executed. If it is false, then the statement after the loop is executed. Now, loop code block. Here in the loop code block, if at any time you have encountered this break statement, like this is the for loop in which it is 1 to 10. But when the number I came to the value 6 only, it has encountered a break statement. So this is the code block. If so, in the code block, anytime you are encountering a break statements, it comes out of the loop and then execute the next statement after the loop. Now, continue. Sometimes you may want to continue. So when the continue statement is encountered, the loop control immediately jumps to the next iteration by skipping. For example, if I is equal to 6, though I'm telling break, because this condition is met, it stops the new. So even though I is 6, I'm saying it to numbers 1 to 10. Right? Now go to. Go to is used to transfer the program control to a label statement within the name function. In my second episode, I've given you some terms of computer programming where I explained to you what a label is there. So I'm saying the syntax of using go to is go to and some label and semicolon. But this label is the name of it is the name of some statement. It is a name of some statement. So that name should follow here, label colon the code. Here we will be seeing your program to calculate the sum and average of positive numbers. Go to jump if the user enters a negative number. So I'm accepting a number as long as the numbers are positive numbers. I want to find out the sum of those numbers. If I'm entering a negative number, then it should stop, right? So here what I'm doing, constant int max input 100. So I'm declaring a constant variable max input 100. Now int I, that is for the counter. Double number, average, sum is equal to 0, right? So here for I is equal to 1, I less than equal to max input. What is max input? 100. That is I is less than or equal to 100. I plus plus. Enter a number. I'm entering some number, right? So I'm entering some number. Scanf, because I've given double, I'm giving the LF here. I'm said number. Now, if the number is less than 0.0, go to jump. I'm saying go to jump. What is jump here? Average. I'm finding out the average. So here what I'm doing, the first number, I'm accepting some number, right? Say the number is 5. I'm accepting the number 5. Now, since 5 is less than or equal to 100, right? Then it will print that number. Now, again, 5 will be incremented to, this 1 is incremented to 2. When 2, it is meeting this condition, I less than or equal to 100. So again, it will ask you to enter a number. Now, suppose I enter a number minus 5.0. If I enter the number y5 minus 5.0, that means it is not meeting this condition. It is meeting this condition, number less than 0.0. I've entered a negative number. If you enter a negative number, then what it does is it goes to the jump statement. That is, it stops accepting more numbers, and whatever numbers you have entered up to that point, it will find out the sum and give you the average. So sum is equal to sum by I minus 1, printf the sum and printf the average, right? So what is the logic of this? Start, you're executing the label 1, statement 1, label 2, statement 2, label 3, statement 3. That is the go to label 3. At this, if I'm saying go to label 3, then it will go to label 3. It will not execute this statement. This label 2 statements, it will not execute because here I've given go to label 3. And then it will stop, right? So this is the logic of the program. So this is about the go-to statement. Now we'll just see some review exercises. Which loop is guaranteed to execute at least one time? These are the most important questions that will be asked in your competitive exams. So that's why I've given you, even in interviews, which loop is guaranteed to execute at least one time? That is for loop, while loop, do while loop, none of them. So you have to select one of them and please check your answers. Optimize the following loop to reduce unnecessary iterations. That is, here we have given for int I is equal to 0, I less than 1000, I plus plus. If I mod 2 is double equal to 0, that means I'm printing printf, that number. That means I'm checking this is a program to print the even numbers, right? So he's telling you to reduce the number of lines of code here. So you to see how you can reduce. How many times the following loop will be executed? So this is the program code. You have to trace this program code and tell how many times it is going to execute. I is 32766. I is less than 32767. Printf the number. So what is this? First time it will print 327666. Then I is incremented to 32767. Now 32767 is equal to 32767. So it will print this number 67. But when it increments, it becomes, this 7 becomes 8. When this 7 becomes 8, this condition becomes false. So it comes out. So effectively, this code is executed only 2 times. Identify the fourth question, identify the error in the following code. For int I is equal to 0, I less than 5, I minus minus. So please identify the error in this code. What is the output of the following code? So this is the following code that is given. You try to identify the error in this particular code. Now these are the answers to them, but so I hope this episode has given you some exposure to the loop instructions. And in this way, you practice applying these loop instructions to the practical problems that you may be encountering in your other course material. Thank you. I request you to kindly like, subscribe to my channel.